morning to everybody. In engineering materials and metallurgy, the unit 2 heat treatment process. In this video, we have to see about the definition of the heat treatment and the annealing processes. In this annealing process, stress relief, recrystallization and spiralizing, normalizing, hardening and tempering of the steels. Then isothermal transformation diagram, cooling curves, a diagram for CCR, hardenability, Zemi and the Kuching test, as tempering, matte tempering, case hardening, carbrizing, nitriding, cyaniding, carbonitriding, flame and induction hardening, vacuum and plasma hardening are the topics which I have to study in this heat treatment unit. First, introduction to heat treatment. Why we are going to heat treatment? Most of the engineering properties of the metals and alloys are related to their structures. Varying the relative properties of micro constitutions can change the mechanical properties. In practice, changes in mechanical properties can be achieved by a process called heat treatment. Heat treatment can be defined as a heating and cooling operations applied to metals and alloys in solid state so as to obtain the desired property of the material. Purpose of heat treatment is to improve the ductility, malleability and relieve the internal stress of the material, regain or redefine the grain size, alteration in magnetic and electrical property of the metals or materials, and to increase the hardness and improve the toughness of the materials. Heat treatment process. There are annealing process, surface hardening process, periodizing process, normalizing process, hardening process and tempering process. These are all the heat treatment process. First one is the annealing. Annealing is the process of heating the material to a particular temperature and then cooling the material by a very slow cooling process to attain the properties like ductility, toughness and desired microstructures. Purpose of annealing is to improve mechanical properties, to improve mechanability, to restore ductility, particularly after the steel has been subjected to cold working, and to remove or minimize segregation of essential constituents of steels, and to alter the microstructure to make it suitable for hardening, to relieve internal stresses. Then we have to see about the full annealing. The main objective of full annealing is to soften the metals, to refine its grain structure and to relieve the stresses and gases trapped inside the metals. Heating the steel to 30 degrees Celsius to 50 degrees Celsius of the upper critical temperature for hypoelectric steel and by the same temperature above the lower critical temperature for hypoelectric steels. At this temperature, we have to maintain at this temperature we have to maintain for some time to enable internal changes take place in the material. Then after some time, after a minute, we have to cooled by slowly. The cooling rate varies from 30 degrees Celsius to 20 degrees Celsius per hour. Process of annealing. Process of annealing is usually carried out to remove the effects of cold working and to soften the steel. The temperature 650 degrees Celsius to 720 degrees Celsius and holding at the temperature for sufficient time followed by slow cooling. The process is useful for especially for mild steel, low carbon steel for removing cold working effects. The process of annealing. X-axis the carbon percentage and y-axis temperature in degrees Celsius. Heating to 650 degrees Celsius to 750 degrees Celsius and wait for some time. The material goes to liquid state and the molten state, and by cooling it will form a solid state. This one is the graphical representation of annealing process. Stress relieving in annealing process. This process is used to relieve internal stresses which develop during different operations like welding, solidification of casting, machining, etc. In this process, the uniform cooling rate is very essential. We have to cool the material slowly. Spheroidal annealing or spheroidizing. In spheroidizing annealing, graphite with iron is the granular form is produced. Prolonged heating causes the cementite to course into spheres, completely destroying the perlitic form. The actual structure is to matrix of ferrite with Fe3C in the form of spheroidal globules. The heat treatment that follows after machining should be easily. This process is usually applied to high carbon steel which is difficult to machine. Heating steels between 650 degrees Celsius to 723 Celsius already we discussed in above graphs. And holding for some time and then cooling by slow process. The cooling rate in furnace is to be 25 degrees Celsius to 30 degrees Celsius per hour. Thank you for watching this video. I believe you understand this topic. Thank you.